This is lesson 171, and we're taking a look at transformation of basic graphs. So today we're going to transform a quadratic parent function and apply horizontal and vertical transformations. Now, there's a whole lot of parent graphs that we're going to be getting down. We're just going to start with one for today because it's one that we've already seen before, and this is the parabola. Now we need to copy this down. We need to memorize this. The elements that we need to memorize is this is what the parent graph form looks like. This is the shape and what it looks like without anything being done for it. If you notice, its starting position is at 0, 0, and it kind of has this pattern when it comes to the points. Now, the standard form of this function, another way of saying is the graphing form of this function, is some a times x minus h squared plus k. Now you might be wondering, like, wait a minute, what the heck is this a, what is this h, and what is this k? What is that going to do? Each of those actually transform our functions. So let's talk about those transformations. Today, we're going to focus on the h and on the k. So every single one of these parent functions, every single one of them, we're just starting out with quadratic, but every one of them is going to be modified by some sort of shifting, and we call that like a translation. And there's a generic form of thinking of it. If you have some sort of graph f of x, if you have some number that you're adding on the outside of your function, we call that the k. And what's going to happen is it's going to shift your graph up or down. Now notice it says plus k shifts up that many spaces. Minus k is going to shift down those spaces. Now remember, it's like, and this is a way to think about it, f of x is y. Well, I'm adding a number to my y value, so obviously it's going to shift up. I'm subtracting a number to my y value. It's going to shift down. But now let's look at the h. Now we know that h is horizontal shift because we're adding or subtracting a number to your x, right? Your x value, the x-axis, that moves left or right. But notice when it says plus h, it's going to shift to the left. Well, the left is the negative direction. And when it says minus, it's going to shift into the positive direction. Now that's so weird. Why is it the opposite for the x? Well, let's take a look at the formula. There's a minus in the formula. Whenever we have a minus in the formula, it means do the opposite. So if you remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. You know how you always added a negative to that b part? Because it says negative b. It means do the opposite. It means add a negative to it. Well, because in the formula there's a negative, that means anytime you do the horizontal shift, you're going to do the opposite because there will always be a negative in that formula. So horizontal shift, you do the opposite. Vertical shift, you do the same. So let's look at a few of these. Just kind of mentally think about it. It says x minus 5 squared. Well, the minus, do the opposite. So I'm going to do 5 spaces in the positive direction to the right, plus 3. I'm going to move up 3 spaces. Do the opposite, minus 4, so shift 4 spaces to the left. Do the same, shift down 1 space. Now let's look at an actual graph here. So what if I wanted to shift this graph 3 spaces to the right? Like, what is that going to look like? Now remember, we have f of x minus h, so it has to be the opposite of what shifting to the right is. Well, shifting to the right is positive. The opposite of positive is going to be negative, so it's going to be x minus 3 squared. Now what does that look like? It literally means every single point is shifting over 3 spaces. If every single point shifts over 3 spaces, that's what your new function is going to look like. What is it going to look like if I want to shift 2 spaces to the left? Well, to the left is the negative direction. The opposite of the negative direction is positive. So it's going to be 2, so x plus 2 squared. And what does that look like? Everything's going to get shifted over 2 spaces right? Wherever it originally was, it's going to get shifted over 2 spaces to the left. Now let's look at the vertical function, or the vertical shift. Vertical shifts plus k, see, do the same, plus k means do the same, plus is do the same. So if I wanted to shift 1 space up, I'm going to move plus 1. And so that means every single point is going to move up 1 space. If it says shift 4 spaces down, do the same. So it's going to be x squared minus 4. That means every single point is going to shift down 4 spaces. So it's going to look like that. Now let's put them together. What if I wanted to shift 3 spaces to the right and 1 space up? Okay, do the opposite, do the same. So to the right is the positive, so it's going to be x minus 3 squared, and then plus 1. So it shifted over 3, up 1. Over 3, up 1. Over 3, up 1. Right? Every single value shifted over 3, up 1. What if I wanted to shift 2 to the left and 4 down? Well, to the left is the negative direction, so the opposite of negative is positive, so it'll be x plus 2 squared, and then it's down 4. Do the same for the vertical, so it's going to be minus 4. So everything shifted over 2 and down 4. So what did we learn today? We have introduced parent functions, and we started with the quadratic function and how to shift it horizontally and vertically. What does the h represent in the transformation of functions? It means the horizontal shift. And for the horizontal shift, you do the opposite. Why? Because in the formula, it's x minus h. So whatever generic function we're talking about, it's x minus h, which means you do the opposite. There's a minus in the formula, so you do the opposite. And then the k, it's f of x plus k. Because there's a plus in the formula, it means you do the same. So it's going to shift your function up or down. This does conclude our lesson. If you have any other questions, please leave them in the comments.